Right, great answer. Let's balance chemical equations. So after knowing what chemical equations are and knowing what chemical compounds are, now we need to balance chemical reactions, right? Now, for me, in grade 9, there's a simple method of balancing chemical equations or chemical reactions, right? Now, we first start by actually explaining why is there a need to balance your chemical reactions. Well, the law of conservation of mass simply states that mass cannot be created nor destroyed in a chemical reaction. What does that mean? See, it means that at the beginning of reaction, if I have an X amount of hydrogens, at the end of the reaction in the product side, I must have that same amount of hydrogens. Are we clear? So to give you an example with hydrogen as a diatomic element reacting with another diatomic element, which is oxygen, it gives us H2O as a product. But H2O has got two hydrogens. Yes? Great. Similar to the reactants, we have two hydrogens. But H2O also contains oxygen with one oxygen. We know that because the subscript here is 1, but we don't write it. But on your reactants, we begin with two hydrogens. Makes no sense, right? So there must be a balance. So what do we use to balance chemical equations? We are gonna use coefficients. Remember, there's a difference between a coefficient and a subscript. The numbers that are found on the bottom of each element those are your subscripts. We do not change or alter those numbers whatsoever. I call them the little handbags. We do not change these numbers whatsoever, nor do we actually ever change a chemical compound the way it is. It's H2O. It's not going to change. You do not have to even put something in the middle. For example, I've seen kids doing this. No, you cannot do that. It stays like that. What we can change and are allowed to change is the coefficients. Those are the numbers. For example, we can say 3, 4, and 6 here, if it was possible. Then those are the numbers that come just before the actual element or compound, the coefficients. That's what we change. Right. We got that in the back. The second thing I want you to know is I'm going to use a pictorial model or models to represent this equation, right? Let's see. First, I have two hydrogens. These two hydrogens, when you draw them, they must be bonded to each other like this. For example, if you were to draw it, you draw one hydrogen. It's not away from the other hydrogen. That would be completely wrong, right? It is bonded together. It's H2. It's not one H and another H. It's H2. So it is bonded together. So that is how you represent them, right? Similarly to another diatomic element, which is oxygen, there's two oxygens bonded together. That's what we start with in the reactants. So these will be our reactants. Right. Now, in the product side, I represent H2O like this. I usually say H2O looks like your Mickey Mouse, right? We have two hydrogens, and we know this because this subscript only applies to your hydrogens. So we have two hydrogens and one oxygen. That is our reaction. So now let's get to the fun part. Now let's balance these chemical equations. Now, by using what? By using this pictorial equation. It works very well for me. So let's start. If I say, for example, okay, I have two hydrogens and two oxygens. Usually the rule is start with oxygens and hydrogens first when you balance. On my reactant side, so I separate them like this. I have two hydrogens. On my product side, I have two hydrogens. That looks about great, right? So on my reactant side, I look at my hydrogens, yeah? And then product, and then we have oxygens. Right. I have how many? I have on my reactant side, I have two hydrogens. On my product side, I have two hydrogens. That sounds good. It's balanced, right? Now let's look at our oxygens. Our oxygens on my reactant side, I have 2 oxygens. There's 1 and there's 2. And on my product side, how many oxygens do I have? Only 1. That creates a problem. We cannot have this. It is unbalanced. Now, here's what I'm going to do. I'm going to try to balance the number of oxygens on my product side. We always balance where there's a need. We give to the needy. So, I need to add another oxygen on my product side. But oxygen, now here's the rule. Since oxygen on my product side is found being bonded to 2 hydrogens, I cannot just add oxygen alone. I must add the 2 hydrogens that are bonded to it. So I'm going to add the whole H2O molecule. Basically, that's what I'm telling you, right? Like this. I add another oxygen. Now I have 2 oxygen. Okay, then it balances the number of my oxygens. But here's a problem now. I have 2 hydrogens on my reactant side. On my reactant side. Now on my product side, the number of hydrogens changed. There's 1, 2, 3, and 4. Now that creates a problem. And where do we balance? Where there's a need. So I need to add hydrogens on my reactant side. Why? Because on my product side I have 4. The numbers have changed. Now, how will I add that? I will need to add a hydrogen. But hydrogens are not floating around one by one. No, these hydrogens exist as H2. So I add another H2 molecule. And then that balances the number of my hydrogens to 4, 4. Now, as soon as I am done, I do some accounting. How many hydrogens do I have? 1, 2, 3, and 4. On my product side, 1, 2, 3, and 4. Okay, my hydrogens are balanced. Oxygens, I have 1, 2 on my reactant side. On my product side, I have 1, 2. Okay, it seems like it's balanced. But if they require you to balance, then using numbers, for example, you must put numbers or your coefficient on your elements or compounds. Then we start to do some accounting. How many H2s did I use? We count them. This is one H2 and this is another H2. So I've used 2 H2s. I put a 2 here. How many O2s did I use? I only used 1. Remember, when I ask how many O2s did I use, I say the molecule, not the atom. There are 2 oxygen atoms, but there is 1 molecule of oxygen which exists in nature as a diatomic element. Similarly to hydrogens, there's 4 of them, but how many H2s as a molecule? There's 2 of them. So I used 2, and then how many water molecules did I use? H2Os. That's 1, 2, and then I have it like that. So that is basically how I actually balance my chemical equations. From here, let's do some more examples, because people don't get it the first time. We're gonna do it more and more and more and more. So let's have a look at another reaction that is easier. Let's take, for example, let's see. Let's take lithium reacts with oxygen. It's a metal plus an oxygen to give us a metal oxide called lithium Li2O, lithium oxide. Now we need to balance this. Good. First things first, in this case, while we're still learning, I'm gonna separate my reactants from my products. And then we begin to draw. So I'm gonna use colors here. Let's say this green one is my lithium, right? And then we draw our oxygen. Oxygen is O2. And then what is lithium oxide? I have 1 oxygen bonded to how many lithiums? 2 lithiums. The first part, the trickiest part, I think, is just drawing them first. 1 lithium plus 2 oxygens bonded together, plus another lithium and another lithium bonded to 1 oxygen, right? Perfect. Now let's balance. Let's balance. Now, I start with oxygens. The rule is start with oxygens and hydrogens. It makes your life way easier. On my reactant side, how many oxygens do I have? I have 2 oxygens. On my product side, I have 1. So I'm going to need to add another oxygen where it is needed, that is on my product side. But I cannot add oxygen alone. I must add the whole entire molecule of lithium oxide because the oxygen is bonded to 2 lithiums. Now I have 2 lithiums and then 2 oxygens, sorry, and then 4 lithiums now. Ne? And then on this side I have 2 oxygens. My oxygens are balanced. Now I have 1 lithium here. Since lithium, now let's balance lithium. Ne? I add another lithium. Lithium is not bonded to anything, so I can add it the way it is at any given time. Does it balance? No. I add another one. Does it balance the lithiums? No. And I add another one. It balances the number of lithiums. So I have 1, 2, 3, 4 lithiums, 1, 2, 3, 4 lithiums on my product side, and then I have 1, 2 oxygens and 2 oxygens on my product side. Then at the end of the day, we do accounting. How many lithiums individually did you use? 1, 2, 3, and 4 lithium. So I'm going to put a 4 here. How many oxygen molecules did you use? O2s did I use? I used only 1, so 1, I don't write it. I leave it like that. How many lithium oxides did I use? I used 2 of them. So I'm going to put a 2 here. Your whole entire reaction is balanced, right? So basically, that's balancing chemical reactions. That is example 1. Let's look at another example. Let's go to example 2. Right? But I think by the end of the third example, you should get this. So let's look at example number 2. Let's take, for example, still an easy one. Let's say, which metal should we use? Calcium reacts with iodine to give us calcium iodide. So this is calcium iodide. First things first, we draw our, obviously you're going to be drawing. So let's choose a color. Let's say this one is our calcium. And then our iodine will be the blue one. So you have iodine, one of the halogens exists as a diatomic element, right? And then on the other side, we have calcium bonded to 2 iodines, to 2 iodines. 1, 2, right? Simple enough, right? So if you are still lost a bit, that's calcium, iodine, and then iodine, and 1 calcium. That is that. So let's balance it. We start with oxygen or hydrogens. In this case, we do not have oxygens or hydrogens. So we're gonna start with either one of them, right? So let's look at it. If I have 2 iodines this side, I'm gonna have 2 iodines on my reactant sides, balanced. Calcium, I have 1 calcium on my reactant side and I have 1 calcium on my product side, balanced. Do I need to balance this equation? No, it is already balanced. So these are some of the equations that you're going to see that they are already balanced. Usually we don't give you this in a test, but it was worth looking at. Right. Then example 3. Let's take a common one. Carbon reacts with oxygen to give us carbon monoxide. Right? Right. So as usual, we start by drawing. So let's say, for example, the yellow one is our carbon, right? And then our oxygen is red. So we have two oxygens bonded together, and then it gives us one carbon and one oxygen bonded together. So basically this is our carbon, OO, and then carbon and oxygen. So this is carbon monoxide, right? Right, for the last time, let's just separate them so that you can see. Great. Now let's go. Carbon monoxide, we start by balancing the number of oxygens. So on my reactant side, I have two oxygens. On my product side, I have one oxygen. That means we need to balance what? The number of oxygens first. And where do we balance? Where more oxygens are needed. Which side is that? That would be your product side. So I put an oxygen here. The rule is I cannot put just an oxygen there. Why? Because it is bonded to a carbon. So I must put another carbon monoxide molecule over there. Now I have two carbons on my product side and then two products on my reactant side. All well and good. Perfect. Now let's see which one should I balance first. Next, it will be my carbons, right? My carbons are unbalanced. I have two on my product side and then two or one on my reactant side. So I need another carbon, and I can simply put another carbon like that because it's not bonded to anything else. So at the end of the day, I have 1, 2 carbons and then 1, 2 carbons, right? Good. It's balanced. Now let's do some accounting. How many carbons individual did I use? 2. Oxygens, just oxygens as an O2. As a diatomic element, I used only 1. So we don't put a 1 there, we leave it. And then we come to our product side. How many carbon monoxides did I use? I used 1 and 2. So that's 2 carbon monoxides. I put a 2 here, and the whole chemical reaction is balanced. Easy, ne? Easy, easy, easy. Good. So let's do, that was example 3. There's a lot of examples that we can use. Let's see. Let me move from here. Let's see. I had a question for you. Yes, this one, the magnesium oxide. Right. So let's say we have magnesium reacting with oxygen, right, to give us magnesium oxide. How do we balance, right? So we move on from example 3 to example 4. From magnesium oxide is formed. Let's draw. So first things first, I'm gonna choose a color. This is my magnesium, and then for my oxygen, obviously I like the red being oxygen, I don't know why. And then my magnesium oxide. So this is my magnesium and oxygen over here, right? Perfect. Now let's balance. We first start by balancing the number of oxygens first. How many oxygens do we have on our reactant side? We have 2 oxygens. On our product side, we have only 1. So can I put an oxygen like this alone? No. The oxygen is attached to a magnesium. I must put the whole entire magnesium oxide right there, right? Perfect. Then if my oxygens are balanced, we have 2 on my product side, 2 on my reactant side. What about my magnesiums? On my reactant side, I have 1. Product side, I have 2. That is unbalanced. So I come back to my reactant side. Since magnesium is not bonded to anything, I can easily add it as an individual like that, and then my whole reaction is balanced. So we do some accounting. I used 1, 2, that's 2 magnesiums, and I used 1 O2, so it's 1, we don't write it, and I used 2 magnesium oxides, right? Chemical equation balanced. Right, the last equation that we're going to do is slightly different. Many of my grade 9s thought it was difficult. When iron reacts with oxygen to give us iron 3 oxide, right? That's Fe2O3. That's iron oxide, aka rust, right? So this is the formation of rust under a moisture, right? Moisture and air or oxygen. Okay, fine. Now let's balance this chemical equation. Like the rest of them, if we want to balance, we first start by choosing a color to represent. We draw the whole chemical equation. So that's oxygen. And then we go on our product side. That's 2 ions, 1, 2. Both of them are bonded to oxygens, like this. So this is my iron oxide. This method for grade 9 works perfectly, right? That is oxygen, 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 and iron, iron. Right, that's 2 ions and 3 oxygens, 2 oxygens and 1 ion. So let us balance. Let's start by balancing the number of oxygens. Now, on my product side, I have 3 oxygens. On my reactant side, I have how many oxygens? That's 2 oxygens. Can I put another oxygen like this and then it balances the whole, it balances the number of oxygens? No. Why? Because oxygen is not just O. It's O2, meaning it's 2 oxygens. This oxygen is bonded to another oxygen. So I'm going to have to use O2. Perfect? Great. Now, does it balance the number of oxygens? No. So sometimes you'll see some of them are a bit longer. It takes longer to balance, but eventually you get there, right? So now I have 4 oxygens on my reactant side. On my product side, I have 3. All right, fine. I go to where oxygens are needed. Can I put another oxygen like this and then we are fine? No. I must put the whole iron oxide molecule or compound, right? I must put the whole compound of iron oxide like this. I've added another iron oxide. Now this creates a problem. I have 1, 2, 3, 4, 5, 6 oxygens on my product side, right? Just like we've been doing, we go back to our reactant side. We have 2. That does not sound right. So I need to add another O2 to see if it can balance. Lo and behold, the number of oxygens are balanced. I have 1, 2, 3, 4, 5, 6 oxygen atoms. Not molecules, atoms. And then on my product side, I have 1, 2, 3, 4, 5, 6 oxygen atoms. Now the oxygens are balanced. Now we go to the ions. On my reactant side, I have 1 ion sham. It's lonely over there. Yeah? And then on my product side, I have 1, 2, 3, 4 ions. All right. Can I put another ion here? Since ion is not bonded to anything, only on my reactant side. Yes. And another one? Yes. And another one? Yes. That makes it 1, 2, 3, 4 ion atoms, and then 1, 2, 3, 4 ion atoms. So the reaction is balanced. How many ions did I use? 1, 2, 3, 4. I put a 4 here. Yeah? And then 1, 2, 3 O2s. Yeah? 3 of them that I used. So it's 1, 2, and 3. And then iron oxides is 1. And then we added another one when we were balancing the number of oxygens. So that makes it 2 iron oxide. Looks like a soccer formation, 4, 3, 2. Yeah? Great. That is how you balance using the pictorial model. I feel like this method works wonders when dealing with many reactions. You can use it for even your double displacement reactions, single displacement reactions. When you do acids and bases, it still works out the same, right? So that is our balancing of chemical reactions using the pictorial model. I hope you've learned something. Adios.